All right, in this section, or this week I should say, we're going to be looking at converting between number bases. This is the last section that we deal with in chapter 4, and I think from when I've taught this class in the past, this seems to be the most difficult section for most people. But this is a really useful concept depending on where you go after college. Specifically, if you go into computer science, there's a lot of applications of these things. But anyways, we've already talked about how to convert between number bases in the parent class, and this is just to sort of reiterate some of that stuff. So for the support class this week, once again, we're not going to be working on prerequisite material so much. We're going to be working on additional examples, additional practice with the material we're already doing in the parent class. So I'm only doing a couple of examples here. And the first one is going to be just a basic conversion. So I want to convert this number, 41032, in base 5. Notice I didn't read that as 41,032 because that's not what that number is. If this were in decimal form, base 10, I could read it that way. But because it's not in base 10, that's not actually what this number is. It's not 41,032. I'm just going to read it as 41032 in base 5. And we're not converting it to decimal, we're converting it to base 9. But in order to do this, I actually will, as an in-between step, start by converting things to decimal, because that is our familiar numeral system. That's a numeration system that we're used to. So the first thing I'm going to do is convert 41032 base 5 into decimal form. And remember, what we do there is we think of each of these place values as representing a power of 5. This would represent the ones place, or the 5 to the power of 0 place. This is 5 to the power of 1 place, 5 to the second, 5 to the third, 5 to the fourth. And so writing this out in expanded form, we know that the 4 here represents 4 times 5 to the 4th power, plus our next numeral, 1 times 5 to the 3rd power, plus. Technically, I don't need to write this one because even though this next numeral represents 0 to the 5 squared power, or 0 times 5 squared, the whole thing is going to end up equaling 0 anyways. But for completeness sake, I'm going to write it out. 3 times 5 to the power of 1 plus 2 times 5 to the power of 0. That's the literal meaning of this. Okay? Now, I'm not going to go through all of the handwritten arithmetic to work this out. I'm going to assume that this goes into a calculator and we just get an answer straight out. This comes out to 2,642. And in this case, it is okay for me to read it that way, 2,642 or 2,642, because the resulting number is in decimal. This is a decimal number. And I could write 10 here to show that it's in decimal, but remember, if we don't put anything down here, it's assumed that the number is decimal. Okay? But this is not really what I'm looking for. I don't want something in base 10. I want something in base 9. And so now what I'm going to do is take this number and convert it using one of the techniques that we talked about in the parent class to base 9. And one of the tricks we talked about for doing that is repeatedly dividing this thing by the base that we're trying to convert it to, and using the remainders of that division as our numeral. So I'm going to start with, what did I say, 2,642 divided by 9, okay? Now, when I divide 2,642 by 9, I'm going to get, let's see, 9 goes into 27 3 times, so this is a little smaller. It must only go in twice. 2 times 9 is 18. If I do the subtraction here, 26 minus 18 is 8. I'll bring this down to get 84. 9 goes into 84 9 times. 9 times 9 is 81. I subtract and I get a 3, bring down my 2 to put a 32 there. 9 goes into 32 3 times 9 is 27, and the subtraction here gives me 5. Okay? Now the 5 is the part that matters. It's not the quotient. The 293 that's left over there is not going to end up in my, it's not going to end up in my numeral. I should back that up. It's the quotient is important, but it's not going to end up in the numeral. The quotient is going to be used in the next division step. So I kind of misspoke by saying that. Okay, circle the remainder as a reminder that I'm going to use that in my numeral. Now what I'm going to do is take the quotient and divide that by 9. So I'm going to do 293 divided by 9. 9 goes into 29 3 times. 3 times 9 is 27. The subtraction gives me a 2. Bring down my 3. 9 goes into 23 2 times. 2 times 9 is 18. Subtract again. This will give me 5 again. So I'm going to have another remainder of 5. Okay. Now the quotient here is still larger than 9, so I'm going to continue doing this division. 32, which was my quotient before, divided by 9. 9 goes into 32 3 times. 3 times 9 is 27. Doing the subtraction here, notice it's the same subtraction we did over here, gives me a remainder of 5. And it's coincidental that I keep getting 5s here. There's not a deeper meaning behind that. It's just what I happen to be getting. Okay, let's do one more division step because I still have a quotient here, and I want to do 9 into 3. So 3 divided by 9, 9 goes into 3 0 times, and then 0 times 9 is obviously 0, subtract, and I get a remainder of 3. Okay, now when I get that quotient of 0 here, that's what tells me to stop, and I have these remainders, okay? And if you remember, we want to write the remainders in the reverse order that we found them. So 3, 5, 5, 5. And this is base 9, so I include that in my subscript. Okay, so that's the answer to this one. And if you wanted to check and see if the answer is correct, what you could do is write this out in expanded form, similar to what we did here, except now we would be using powers of 9 instead of powers of 5, and see if you still get 2642 in decimal. That way we would be showing that this number, base 5, is the same as this number, base 9. And so that would indicate that we converted correctly. Okay? This example right here, we're comparing two numbers, FF and base 16. Remember, base 16, we call that hexadecimal. So this is FF in hexadecimal. And this is the number 5555 in base 6. And when I say compare two numbers, what I'm doing is I'm trying to determine if one is bigger than the other or if they're equal. So I'm gonna add to this using less than, greater than, or equal to. So I want to put that symbol in between these two to describe the relationship. The way I need to do that is convert both of these numbers to base 10 so that I can see both of the numbers in the same base, making it easier to compare the two of them. Now I don't have to convert them both to base 10. I can actually convert them both to whichever base that I want, as long as they're both converted to the same base, and then I can compare them directly. But since it's going to be the least amount of work to convert these to base 10, that's what I'm going to do. So first of all, in base 16, remember that these place values represent powers of 16. This is 16 to the power of 0, which is the same thing as 1. This is the place value here represents 16 to the power of 1. And remember, in hexadecimal, when we start using letters, it's because we're using number bases that are greater than 10. F, if you remember from the parent class, represents 15. So this is 15 times 16 to the first power plus 15 times 16 to the power of 0, which is just 15 times 1, or 15. So writing this out in expanded form gives me this. And once again, we're going to bypass all the written arithmetic because it's not really worth our time. This would come out to 255. I want to do the same thing to this numeral here. I want to convert this from base 6 into decimal so that I can directly compare it to that number there. These are powers of 6. So this would look like 5 times 6 cubed plus 5 times 6 squared plus 5 times 6 to the first power plus 5 times 6 to the 0 power. Okay, once again, if you put that in a calculator, this gives you 1295. So we've converted both of these to decimal. The first one is the same thing as 255 in decimal, and this one is the same thing as 1295 in decimal. This number is clearly larger than this number, so for the sake of comparison, I would write this. FF in hexadecimal, or base 16, is less than 5555 in base 6. Okay? All right, that's going to wrap it up.